Hello everyone. I am making this video particularly for my fellow math teachers out there, and I believe students will also benefit from this video. Quadratics. There are a lot of things students should learn under quadratics before they graduate. And based on experience, I have noticed that many students only learn few things here. How to solve, how to graph, and some few things. So today, let me highlight, there are a lot of them, but I am going to highlight the fundamental ones. Quadratics. Let students understand the difference between expressions and equations. That is under introduction. So we have expressions. Expressions and equations. What is the difference? You should know that quadratics can appear to be in the form of ax squared, where you have only a single term. This is an expression, right? You can have ax squared plus bx. You could have ax squared plus c, and lastly ax squared plus bx plus c. This is the general form where you have all the terms available. This is the leading term, this is the middle term, and this is the constant. And all of these four are referred to as expressions, right? Why do we have this term all the time? Because a can never be equal to 0, but b, c can be 0, right? This is why you have quadratic monomial, quadratic binomials, and quadratic trinomials. Your students should learn the difference between these four. Equation is when you have equality sign attached to either of these four. For example, if you have ax squared plus bx plus c equal to either, in most cases 0, but it could be any other thing. Because of the equality sign, we say this is a quadratic equation, while these are quadratic expressions. All right, this is under introduction, right? Intro, number one. Then number two, it's very important for your students to know the different forms of quadratic equations or quadratic expressions. You could have the form of ax squared plus bx plus c. This is what? The standard form. This is the standard form. I don't have to write everything, but as I write, I explain. You could have the factored form, like a multiplied by x minus p. P is a constant. X minus q is a constant. So this is factored form if the quadratic is being factorized. You could have the vertex form. They are all forms of quadratics. A x minus k, right? Plus c, or h. In most cases, you see h here. This is what we call the vertex form of quadratic expression. This is the factored form, and this is the standard form. These are the forms you can see quadratics. And you should know that k and h here are constants. So you may see DE. They are just representing values. This is a value of x, exactly where it divides the curve into two. So we call it what? Line of symmetry. That is when x is equal to k, this is going to give us 0. Exactly where it crosses, it divides the curve into two equal parts. And this h is either the minimum or the maximum. But in many textbooks, you see h here and k here. But it doesn't matter. I know they are only representing numbers. So another thing students should learn is the parabola. We have not come to the solutions yet. Parabola, very important. Number 3, parabola. Parabola is the shape of the graph of quadratics, the shapes. You can see a parabola like this or like this. These are the two forms. We call this open up or upward opening. It depends on the context. Open up, and this is open down. So when does this two happen? This happen when A is positive. This happen when A is negative. So for example, here you may see ax squared plus bx plus c, for example, and this one negative ax squared plus bx plus c. When the leading coefficient is positive, you should expect an open up parabola. Is it the only things we should learn under parabola? We have a lot of things, but they are not mentioned here, but let me just discuss about them. You know, parabola crosses x-axis. So when does the parabola crosses x-axis? A parabola crosses x-axis when the discriminant, maybe I should wait when we get to discriminant. I'm going to explain that better. So if you have y-axis and x-axis, and it happens you have a parabola like this, there is what we call a line of symmetry, which I have talked about earlier, exactly where this curve is divided equally. So what you have here and here are exactly the same. So the value of x here is what we call, x equal to, should I call it k or h? Let me call it k, because I could remember I used k, right? So how can you determine exactly the point where it crosses x-axis? You can always take this equation, x is equal to minus b divided by 2a. It's very important for your students to know this. Exactly the value of x, exactly the point where the curve is divided equally is at this point. And what is b? B is the coefficient of x. A is the leading coefficient. Just take minus b divided by 2a. It will give you the value of x at that point. And when you have an open up parabola, you always get a minimum value of y. So what is the value of y at that point? The value of y at that point can be obtained by taking 4ac minus b squared divided by 4a. Once you evaluate this, you're going to get the corresponding value of y at that point. You know, at this point, which is the turning point, we have a value of x and y. So the value of x there can be obtained by using this formula, and the value of y can be obtained by using that formula. What is next? Then the method of solving quadratics. We have the method of solving quadratic equations. Using general formula, which is what? X equal to minus b plus or minus into square root of b squared minus 4ac divided by 2a. This is the general formula. And this value under the square root b squared minus 4ac is what we call the discriminant. We are coming to that. Secondly, you can solve quadratic equations by factoring. I've shown you how the factored form looks like if you have a x minus p x minus q equal to 0. So the expression to the left hand side can be factorized as this when the leading coefficient a is not 1. But if the leading coefficient is 1, you may not see this e. You will only see something x minus p times x minus q. And you can solve these quadratic equations by completing the square. Completing the square method. And through the completing the square method, we can derive this important formula. Which other method? We have the graphical solution, right? graphical solution. You can graph a quadratic equation exactly the points where it crosses x-axis. Those 2 points are said to be the solution to the quadratic equation. All right, now let us talk about the nature of solutions. Nature of solutions. What do we mean by nature of solutions? Sometimes you may solve a quadratic equation and realize two different values. You may solve a quadratic equation and obtain one solution. This is why it appears twice. We say one twice. And you could also obtain a complex solution. So how does it happen? Remember, the discriminant d is what we call the discriminant, which can be obtained by taking b squared minus 4ac, which is this value under the square root. If you simplify this value and you realize 0, then it implies that that quadratic equation will have only one solution twice. And we call it real because the value is real and equal roots or zeros. Sometimes you may evaluate it and you realize a value which is positive number. It is not 0, but it is a positive number greater than 0. In that situation, you're going to obtain two solutions, but different, real and distinct solutions or roots, real and distinct roots. And the last category or nature of solution is when you realize this value is negative, which is less than 0, then you have only imaginary roots. Imaginary roots. That is when you have complex solution. So this is the nature of solutions. It is also very important for your students to learn the relationship between what? Roots of quadratic equation. Number 7, your students should learn the relationship between roots and coefficients. Roots, they are the solution, right? Coefficient, I'm referring to a, b, and c. You know, you have a squared plus bx plus c. Those a, b, c, they are the coefficient. We call them the constant coefficients. And the relationship between the roots and the coefficients. This is under the symmetrical function of quadratic roots. You should know that if, for instance, you solve a quadratic equation and you realize the roots to be alpha and beta, for example, let's assume these are the two roots you obtain. So one relationship is that if you take alpha, you multiply by beta, it is simply the same thing as what? Is it C divided by A? Yeah, C divided by E. And if you take alpha, you add it to beta, this is the same thing as what? Minus B over E. Yes, minus B over E. Instead of solving, maybe you're asked to find the product and the sum of the roots. You don't have to solve that quadratic equation. Though you can do that, after the solution, you multiply or you add the two roots. But taking C over A directly will give you the product, and minus B divided by A will give you the sum. And this is the relationship between the coefficients and the roots. And if you want to form a quadratic equation, forming quadratic, let me use QE, quadratic equations from roots is very important, from the roots. Maybe you are given the roots of quadratic equation and you are asked to find the quadratic equation. You have alternatives. You can use the formula which says that what? X squared minus into alpha plus beta, or you can simply say the sum because alpha and beta, they are the roots, right? This is the sum of the roots times x, then plus the product alpha times beta. So even if you are not given the roots, provided you have the quadratic equation, you can just find alpha plus beta by taking minus b divided by a, bring it here. So either alpha plus beta or minus b divided by a, or you can even write sum of roots inside. This is equal to 0. This will give you the quadratic equation. And you can also take the product like x minus alpha times x minus beta. You multiply together, you're still going to get that quadratic equation. You can see that this is x times x, which is going to give you x squared. The middle terms will be what? Alpha plus beta times x. And negative alpha times negative beta will give you alpha beta. You see, in most cases they are the same, forming quadratic equations. From given roots, if you're given the roots, you can either use this one or this one. But the first one, even if you don't have the roots, you can apply this formula because you have c divided by a and minus b divided by e. Another thing your students should learn under quadratics is quadratics inequality. Very important. Quadratic Q inequality. You may see a quadratic equation in the inequality in the form of ax squared plus bx plus c. Instead of equal to 0, you see greater than 0. This is an inequality. Or you may see less than 0, or less than or equal to 0, or greater or equal to 0. So how do you solve these quadratics? In this situation, you don't get two values, rather interval. Take for instance, if you have a quadratic like this, the graph of quadratic. These are the roots, alpha, beta. And it happens that it stated that it is greater than 0. So where it is greater than 0, you can see this is where y is greater than 0, because we are talking about values of y. This entire expression is a value of y, remember. So it is greater than 0. Anything below the x-axis is less than 0. So you are marking these sides. So your solution, you can see it is from negative infinity down to alpha, right? Including alpha. Union from beta way down to positive infinity. This is how to write the solution of quadratic inequality. And if it is less than, you have to consider this portion. This is where it is less than. This is where it is greater than. You see, for this one, it is going to be just from alpha to beta. Then your student should learn about this solution to system of linear and quadratic equations. Sometimes you may be given a quadratic equation together with a linear equation to solve simultaneously. You can make one of the variables in the linear equation, substitute it into quadratic, solve, then substitute back. In that case, you get pair of solutions. So your students should learn system of linear and quadratic equations. I don't have to show you how to solve them. System of linear and quadratic equations. Yes, they should learn how to solve system of linear and quadratic equations. Your students should also learn the real-life application of quadratics. Sometimes it is applicable in projectile, right? Maybe someone is standing here and he decided to kick a ball. The ball will go like this. It will reach a maximum height. It will start dropping. You understand? So this is one of the applications of quadratic equation. And also, they should be able to translate words into quadratics. This is word problem questions under quadratics. Very important. Word problem. Word problem, also very important. And they should also learn the common mistakes, also very important. Common mistakes. You should know that if you have a quadratic equation, that a can never be equal to 0, right? And if you have rational quadratics, you should know that the denominator cannot be 0. These are some of the things you should be very careful about. Well, I think I have tried. There are a lot of things under quadratics, but these are some of the very important things your students should learn under quadratics.